Hello sir, I'm Lim Yu Han. Today we want to presentation smart crowd control system. So my group member have Lao Mankin, Peng Zun and Nong Wai. So first talk about the background story for the system. So the idea for the system is from the pandemic. So pandemic has restricted the gathering of large social group in the public. So therefore it need to have a system to control the large crowd. So but the large crowd based on the individual may be proven difficult to manage customer in certain premise. Therefore, the smart crowd management system proposed has combined various technologies and methods to manage a crowd dynamic during the endemic. So for the history of crowd control can be tracked back to 19th century. Crowd control is a public security practice that involves managing large crowd in order to prevent crowd crises, afraid fight, involve drunk and more. So at that time it don't have the official crowd control units, so their patterns their job is to simply keep the crowd in check. So next we talk about our objective. So in our project objective is to track the people who are invoking the standard operating procedure, which is SOP, such as the bed, mask wearing and social distance. So second objective is to summarize the infection rate of the location and crowd density to provide to the user with alert and notification. Last is to send alert or notification to the owner to alert the staff and have people who are not following the SOP. So that's all for me. I will pass to the next members. Thank you.
Thank you, Johan, for his presentation previously. My name is Peng Zun, and I would like to explain about the architecture diagram for our smart crowd control system. First, I would like to talk about the data source. Surveillance camera, infrared cameras, RFID tags, and sensors such as thermometers are used as devices to input data over the internet in real time. Cloud computing is used to process the data collected from the area, whether it's a hall, supermarket, or food court. AWS Iot Core is used to retrieve data from the various devices, and the data will be stored into the Amazon S3 bucket. The data stored will then be sent to Rekognition for analysis, whether in every frame, data such as temperature of a person and the availability of wearing a mask will be detected. Useful data recognized to be stored in Amazon DynamoDB, such as people count and situations, are stored as queries for easier information access. Amazon SNS is used to generate messages to notify on crowd limit in the particular area. Information of people such as whether they wear masks or not, or their forehead temperature. Amazon Amplify has been used as a web-based user interface to access data from the system. The application will require user authentication with the help of Aws Cognito to ensure a safe and secure way to access the data. Post API call for Amplify and Lambda connection is then used to retrieve data from Amazon DynamoDB with the help of Amazon API Gateway. And thus, the users are able to access all the data from the smart crowd control systems via cloud using their devices such as smartphone or laptops.
My name is Nong Wai, and I will do the demonstration for the Iot Core Configurations as well as the message passing to S3 bucket. First, we will need to create the IoT things for our system, which will be the motion sensor, camera, and the screen. First, we will choose these various single things, and we will enter a name. We will do it for the motion sensor, and we'll just follow the default settings. And for the certificate, we will auto-generate a new certificate. And for the policy, we will use the default policy provided. And in this page, we will be needed to download all the certificates generated for future users. And the IoT thing will be created. For the setup of real IoT devices, we will use a simulation to mimic their real IoT device behaviors. Here we have 3 directories, which represents the devices directory. And in the directory, we will be needed to insert their root certificate, the private key, the public key, as well as the root CS certificate for the devices. And we'll be needing a script to mimic their IoT behaviors, as well as connecting through each other through the IoT cloud. And on each terminal, we will be needed to install the AWS IoT SDK, which are already installed in the terminals. Next, we will configure the device flow, which is how the devices are communicating within each other. And the flow will be the motion sensor sensing the movement of individuals, and it will send the trigger message for the camera to capture a photo, and the captured photo will be sent to the screen to be displayed. Now we will associate the device models to the real IoT devices, which is the motion sensor, camera, and the screen. And we will associate the devices. For the motion sensor, we will be using the Raspberry Pi. We will be using the SCSR 501 motion sensor. And for the camera, we will be using Raspberry Pi camera, and for the screen, we will be using Raspberry Pi screen. Before I can deploy the things flow, we need to create a flow configurations, which can be shown here. For the configuration, we will use the things flow ARN, which is on the Amazon US. And for the target, we will be deployed to the cloud. And the things associated will be the motion sensor, camera, and the screen. And the trigger information is described before in the flow. Now we can deploy the flow configurations and run our devices. First we'll deploy the configuration. And now that it's deployed, we will run the mimic script for the mock devices as well as the communication between them. First we'll run the motion sensor. And the motion sensor will be connected and will trigger the motion detected message and send it to the camera. The camera will receive the trigger message and will capture the images, and then it will be sent to the screen, and the screen will display the captured images. Now we will do the configurations on the IoT rule to pass the captured images to the S3 bucket. And first we'll navigate to the IoT section, and under X section we will choose rules, and we will configure the rules to store images into the S3 bucket as shown here. There is a simple rule where the query statement is selecting all of the images from the camera capture finish topic, which is the topic where the camera will upload the capture images to the topic, and the actions will be store the messages to an Amazon S3 bucket. And after this rule is created, and from the flow as shown before, which is the motion sensor to the camera to the screen flow, we will have a MQTT message being sent to the recognition store S3 bucket as we configured before, and this is the message received. We can try to download it and see the contents. And as you can see, for the content, it will be a JSON format, which will store the additional metadata such as the capture image datetime, location, as well as the images being converted into the base64 format, and it will be reconverted back to JPEG or JPG format after this using a lambda function.
My name is Bankin, and I'll now be demonstrating the AWS Recognition, Lambda, and DynamoDB integration. First of all, we'll need to create a role for this process. So we go to the Identity and then Access Management Service. So under here, we need to create a role. So to create a role, we need to just select the policies that we need and then click create role. So I've created the role beforehand. So under the roles here, you can see created LB rec, which is a lambda recognition permission here, and then we'll be having these policies. And then after creating the role itself, we'll go to the lambda function. So this lambda function will actually help us to get the images from the S3 and then analyze them, and then before we actually create a table in the DynamoDB and storing all the information that we processed it. So under the functions here, we create a function. So we choose author from scratch, give the function the name, and then we choose the runtime of Python 3.7. And then under permissions, we use an existing role. And then an existing role, we'll be choosing the role that we actually created just now. So I've created this function beforehand. So here's the function itself. So in the function, we'll be actually implementing the coding. So there will be 3 Python scripts here. The main one, PPE, and JSON to JPEG. The JSON to JPEG will actually convert the JSON format string from the Iot Core, and then we convert it into the JPEG format of the image. And then the PPE is actually going to be used on the images to detect the use of face masks for people, and then who is wearing face mask and who is not wearing face mask. And then the main function here will be, we will create a table that's named images, and then we'll be storing all the attributes in here, all the information that we need. And in here, you can see that we use the detect labels function from the recognition library. So detect the environments labels, and then we store that. And then here you can see that we will store everything to the DynamoDB. So once we click test, we'll actually run the code, and then once it's succeeded, it will show the status succeed over here, and then there'll be a log of showing all the results itself. So if you go to the DynamoDB tables, you can see that there'll be one table here, images, and then we explore the table items. So you can see that all the data itself is stored in here with their labels, location, number of people, race, and other attributes that we have.
And I'll be demonstrating on how to create a RESTful API using the AWS API Gateway Service alongside with Lambda and DynamoDB integration. So for this progress, we will actually need to create a role first. So under the Identity and Access Management, which is IAM for short, we'll be creating a role. So to create a role, you just click Create Role. And then we choose AWS Service and choose Lambda as the use case. Click Next, and then we'll be selecting the policies that we need. And then next, we give a role, we give a name to the role, and then create the role. So I've actually created the role beforehand. So the role is called Lambda Dynamo, and then you have these following policies. So after we create the role itself, so we go to the Lambda. So under the Lambda, we need to create a function. So we choose auto from scratch, give the function a name, and then we choose Node.js 12.x, and then under permissions, we choose use existing role, and then we choose the role that we created just now, and then we create the function. So I've created the function beforehand here, which is named Crow API. So this function actually search the DynamoDB using the primary key and the secondary key that we entered here, and then get the information in JSON string format. And we're integrating this with the API gateway. So we'll test the code to see if it runs. So if you see that it succeeds, and then you can see the response here in JSON code. So we go to the API gateway to actually set it up. So we need to create an API, and then we select RESTful API. So under here, we give the API a name, and then we give it a description. We create the API. And then under here, under the actions, we need to create a resource. So we need to create a proxy resource. So in this options, then we create the resource. So it will straight away pop up this any setup. So any setup, we'll be choosing the Lambda function that we actually created. So the name of the Lambda function is called Crow API, and then make sure the region is actually correct. And then we'll choose save. It asks you to you give permission, then you just click OK. So we have successfully created the method and the resource. So now we can actually try to deploy the API. So we choose a new stage, give the stage a name, description, and then we deploy it. So once we deploy it, we'll get a invoke URL. So we can actually test this using the URL. As you can see, we don't actually have the information here yet, but this is actually here. So we can see that the Lambda actually got the information from DynamoDB. As you can see, you get the information here.
Now I would like to demonstrate AWS Cognito. This can be done by first creating a user pool and user authentication, which can be done here. By managing user pools, we can create new one. We call it flow. We can go for thorough steps. From here, we can select email address or phone number, but we can just select username and email address. Recommendation for sensitive is okay. Any standard attribute to require, we put a standard for email. Next, minimum length by 6. We can just make a simple password from this, which is just like remove numbers, special characters, and also uppercase letters. It also allows users to sign themselves up and 7 days expire, which is all right. We do not really require multi-factor authentication for this demonstration, but it's better for safety and security purposes. Email only because we have registered email, phone number to verify. From here, we can create a new role, which is crowd pool demo, and we can acknowledge the sandbox environment. Where we can set the region to US East Virginia and use Cognito as default, and verifications SMS. Next, we can remember. Okay, from review, it looks all fine. Then we can create our pool. From here, we can continue to add a domain name, which is for our demo. Which is here, we can check our availability and we can save changes. From the app client settings, we can set from here, we can add one. And name. Enable legacy and create application. Okay, from here we can create that application client settings. We can select all and implicit grant, select email, an ID, profile, and save changes. For the callback ID, we can just add HTTP. Okay, then from here we can launch the hosted UI for username sign up. Here we will receive a verification code which can be accessed through mail. Configuration. From here, we are sent to localhost, which is stated on our callback URL. And we can change this to access websites which are sensitive and has our data from the smart crowd control system. Now I would like to demonstrate AWS Amplify. First, we can begin by hosting a web application on the AWS website by clicking here. Then we can continue by getting started hosting the Amplify. We can select GitHub, which will be having the Amplify code so that we are able to run the application, which can be accessed through websites. Next, we would like to select a repository which is available in the GitHub and select the branch which we have produced from the repository. Next, we would like to access the app name, which is all right, repository details, and we can begin to deploy. Once it has successfully deployed, we can continue to wait for it to build and verify so that we can access the website. Once the Crow web application has been deployed and verified, we can access the link as shown below. Then from here, we are able to register our account. And has a basic security feature for passwords. where it requires uppercase and also symbol characters. We can register another name. From here, we can register a new account, and we will require an email confirmation. For the verification, we can set here by verifying the email, and it will be automatically verified. From there, we can log in. We have access to the cloud navigation system. From here, then we can log out.
Hello sir, my name is Lim Yu-Han, and today I want to demo the SNS Simple Notification Service. So first we go to search bar and type the SNS and click the Simple Notification Service. So after that, we go to the topics and the navigation bar and create the topics. So we just simply type the names. Demo 2. So after that, we just simply create. After we create, we need to add the subtraction. So because the subtraction needs some trigger from the lambda, so we need to go to the lambda and trigger it. So after that, we go to the lambda and create a function name called SNS lambda, and then trigger the SNS inside the lambda function, and add the soft code index.js inside here. So it will trigger the SNS and record it. So after that, if we want to publish the notification to the users, so we just go back to the topics and go to the send message and click here and type the subject of the message, so simple demo 1, and drop the message inside here. After that, just click the publish and it will send the message to the users. That's all for me. Thank you.